Hello students, welcome to class 12 physics. In this video we are going to solve illustrations of chapter number 8 electromagnetic waves. So first of all let us solve the illustration number 2. A plane electromagnetic wave of frequency 25 MHz travels in a free space along x direction. So here what is given, that the wave propagates along the x-axis and the frequency of the wave is 25 MHz. At a particular point in space and time, E vector is 6.3 j cap volt per meter. What is vector B at this point? So electric field is given and it is along y-axis. Wave propagates along x-axis and we need to find the magnetic field. So we will be finding magnetic field and its direction will be z-axis, because we know that electric field, magnetic field and the wave propagation are mutually perpendicular to each other. So all the three will be having one of the axis. So if electric field is along y-axis, wave propagation is along x-axis, then but obviously it will be the magnetic field will be along the z-axis. Now here we are having E vector, we need to find B vector. So we can use the equation B equals to E by C. Here E is given as 6.3 and C is 3 into 10 raised to 8. So when we calculate this, we get 2.1 into 10 raised to minus 8 Tesla. Thus, vector B equals to 2.1 into 10 raised to minus 8 K cap Tesla. So students, we need to find this numerical. Now let us solve numerical number 3, that is textual illustration 3. The magnetic field in a plane electromagnetic wave is given by Vy equals to 2 into 10 raised to minus 7 Tesla sine 0.5 into 10 raised to 3x plus 1.5 into 10 raised to 11 t. What is the wavelength and frequency of the wave? So here we are given the expression of the magnetic field, and from this equation we need to find the wavelength and the frequency. So this can be compared with the general equation. We know that the equation for wave, that is E sine kx minus omega t. So here we can use this equation. From this equation, when we compare, here E stands for the amplitude, so this part is the amplitude. After sine function we are having kx plus or minus omega t. So here we are having this term as kx. We are already having x, so this value denotes k, that is the wave vector, plus 1.5 into 10 raised to 11 into t. So here omega is 1.5 into 10 raised to 11. So comparing that with the general equation, here we are given Vy equals to B0 sine kx plus omega t. So here B0 is nothing but the amplitude. So when we compare that equation with this given expression, we get B0 equals to 2 into 10 raised to minus 7 Tesla. Wave vector is 0.5 into 10 raised to 3 radian per second. 0.5 into 10 raised to 3 radian per meter, and omega, that is the frequency, is 1.5 into 10 raised to 11 radian per second. So from this equation, here we need to find the wavelength. So we can use the equation of wave vector, that is k equals to 2 pi upon lambda. Taking lambda as the subject, we get lambda equals to 2 pi by k. So using this formula, we get 2 into 3.14 upon k, that is given as 0.5 into 10 raised to 3. So when we solve this, we get 1.256 into 10 raised to minus 2 meter. Now we need to find frequency also, so we can use this equation omega equals to 2 pi f, that is the frequency. So taking frequency as the subject, we can use this formula f equals to omega upon 2 pi. Here omega, that is given as 1.5 into 10 raised to 11 upon 2 into 3.14. So when we calculate this, we get 2.388 into 10 raised to 10 hertz. So students, you may note down this numerical. Now let us solve the second part of the third illustration. The magnetic field in a plane electromagnetic wave is given by By equals to 2 into 10 raised to minus 7 t sine 0.5 into 10 raised to 3x plus 1.5 into 10 raised to 11 t. Write an expression for the electric field. So here the same way as we have got the expression of the magnetic field, we can find the expression of the electric field. So we can use the general equation for E vector also. E vector equals to E0 sine kx plus omega t. So here kx and omega t, that is already given in this expression. We can use the same, but we need to find the amplitude E0, and for that we can use the equation C equals to E0 by B0. Taking E0 as subject, E0 equals to B0 C. Now here in this expression 2 into 10 raised to minus 7 is B0, that is the amplitude of the magnetic field. So using that, 2 into 10 raised to minus 7, C is 3 into 10 raised to 8. So when we solve this, we get it as 60 volt per meter, that is E0 is 60 volt per meter. Here in the expression it is given as By, that means what? The magnetic field will be along the y-axis. So here B vector oscillates along the y-axis, and it is clearly given that wave propagates along the x-axis. So electric field will be along the z-axis. So equation can be written as E equals to Ez. To denote that it is along z-axis, we can write Ez, that is equals to E0 sine kx plus omega t. Now use the values of E0, k and omega. That is Ez equals to 60 sine 0.5 into 10 raised to 3x plus 1.5 into 10 raised to 11 t volt per meter. And in the vector form, we can also denote by the unit vector, that is k vector. So E vector equals to 60 sine 0.5 into 10 raised to 3x plus 1.5 into 10 raised to 11 t k cap volt per meter. So this is the expression of the electric field vector. So students, you may note down